Hello students, this is Vimala. Today in this session we are going to discuss about the various logic gates which reside in the subject called Digital Computer Fundamentals. Let's get into the session. These are all the contents that we are going to discuss on today. Basics of logic gates, NAND gate and NOR gate. As we all know that today we are living in a technological driven world. So the technological devices control everything around us, and the electronic goods around us like TV, fridge, washing machine. So let's think, what is the behavior of the particular electronic device? For example, if we want to listen music, we can use a music player and we can simply switch on the player to play music, and once we have done, we can simply switch off the player. Okay, so what is the behavior of the MP3 player? We can play music, we can stop the music, we can forward, or we can record and do some, we can backward too. So next, let's take calculator. So what is the behavior of the calculator? So we can perform some arithmetic operations like addition, subtraction, division, multiplications, and all. That's the behavior of the calculator. Now the question is, how do electronic devices works? The answer is very simple. So every electronic device having a small circuit that can be control machine and the process information. And this electronic circuit can be analyzed and simplified by the Boolean algebra. Okay, so at the end of the session, we all come to know what is a basic idea to design the electronic circuit. Let's begin with how the computer works. So as we all know that these are all the basic components of computer. That is input-output device, CPU, monitor, everything. First, by giving the power supply, the system gets started to work, and then the input we can give by using mouse or some keyboard. For example, if I want to add any two number, I can give by using this keyboard or mouse, and that information will be go to the CPU called Central Processing Unit, and there the informations will get processed. Once it has done the process, then we'll get the output through this monitor. Okay, so the monitor finally reveals the output. Let's see the real life example of input-output process. For example, when you switch on the light will get glow. Okay, once we don't want the light, we can simply switch it off. Once we switched off the light, then the light will stop glowing. So this is what the simple input-output process. Here the input is switch on or off, and what will be the output? The light will get glow or not. So simply we can describe the behavior of the integrated chip using some logic gates. For example, we can do some logical operations like addition operations. Let's take two input 4 and 7. The answer will get 11. So once we change the value 2 and 3, the answer should be 5. 11 is not a good answer. Likewise, we can have any number of inputs. So as we have already discussed, the answer will be Boolean value. Boolean means either true or false, 0 or 1. The result will be only based on this, either true or false. Okay. So the logic gates which is used for making the process well, and for especially input-output process. So we can describe the behavior of the integrated chip using some logical gates. Either it can be AND or NOT gates. Okay. So the logical gates only work with the Boolean values. Boolean values means either 0 or 1, or we can say it true or false too. The input and the output of the logic gates which will be described in the truth table. So we'll discuss this. So everything is based on input-output process. The Boolean algebra was developed by English mathematician George Boole in between 1815 to 1864. So every day we have to make a logical decision. For example, should I carry computer science book every day? So the answer might be yes or no, which means logical operation, either true or false, yes or no, both are same. So based on our everyday activity, he has developed the Boolean algebra, especially for the digital computer. So in digital computer is everything is based on input-output process and zeros and ones. So these are all the logical operations which is performed by logical operators. The logical operations are AND, OR, and then NOT. So these are all three basic operations which are performed by logical operators. Let us discuss one by one. So this is the logic gates. That is, a gate is a digital circuit which operates on one or more signals and produce single output only. So basically it's a digital circuit, and the input and output signals are denoted either by 0 or 1. So this is a symbol of AND gate. So it gives only high output if all the inputs are high. Okay. So here A and B denotes input, C will be an output. And we have the AND operator. That means it performs some logical multiplications and denoted by dot symbol. So here we can have two input possible, that is 0, 1, 0 and 1. Again 2 zeros and 2 1. So these are all the possible input of two value of A and B. So here we have to perform logical multiplication. So the first thing that we have to multiply the two input values of A and B first. So the first thing we have to multiply 0 and 0. The result we get 0. And then we multiply 0 and 1. The result will get 0 once again. And then 0 and 0, 0. So when we multiply 1 into 1, we'll get 1 as an output value. Okay. So here hence it proves that both the values should be high when we get the high value. Even a single low value included will produce the negative result in AND gate. So we always remember the simple multiplication for this AND gate. Okay. Next we move on to the OR gate. The OR gate, it's an electronic circuit that gives a high output, that is 1 if one or more of its inputs are high. So this is a logical symbol for OR gate. A and B are input, and the output of Y equal to A plus B. And this is the OR operator, and it performs logical addition which denoted by plus symbol. And this is the truth table for OR operator. So here also the plus symbol we use, that is both A and B are two possible inputs, and we have the same input of 0, 1 and 2 zeros and 2 1. Here we have to perform the addition operation. For example, 0 plus 0 will produce 0, and 0 plus 1 will produce 1, and 1 plus 0 will produce 1, and 1 plus 1 will also produce 1. So here, even if any one of the input are high, the output will be high. So any one input may be 1, so the result will be 1. So we have to remember the OR operator will perform the logical addition. So let's move on to the next gate, that is NOT gate. So the NOT gate is an electronic circuit that gives some negation value, that is an opposite value. Okay, so it performs some logical negations, and it denoted by hyphen, that is a minus symbol. So it operates only on a single variable. So we have only a single input A. So the input may be either 0 or 1. So what will be the output? As I have already told you, it gives opposite value. So if you are giving 0 as an input, we'll get 1 as an output. If you are giving 1 as an input, and we'll get 0 as an output, just opposite to the input value. So this is the NOT operator, and it specially performing the logical negation, which means it produces the complement value, that is the opposite value. Okay, the next one is NAND gate, and it is known as universal gate because any digital circuits can be implemented with the NAND gates alone. So it is a combination of AND gate and NOT gate. So the NOT plus AND gate which produce the NAND gate. So the combination of both AND gate and NOT gates. Okay. So here we have the truth table. The first we have to perform the AND operation, and then by using this we have to perform the NAND operation. Here we have two input called A and B. As usual, we have to give two inputs like zeros and ones, and we have to perform the AND operation as usual, which means we have to perform the multiplication, and then we have to perform the NOT operations on this AND, which means we have to give the opposite value to the value. So here we have the AND operations. We have to perform some multiplications like 0 and 0, and 0 and 1, 1 and 0, and then 1 and 1. So as we all know that it produces only high output when both inputs are high. So and we have to perform, the next one is in the NAND gate, which means we have to perform the NOT operations on this AND, which means the complement of value for this. So here we have the 0. The opposite value of 0 is 1. And again we have the next value is 0, and then opposite value of 0 is also 1. Likewise, and the 1 opposite value of 1 is 0. So finally 1 1 1 0 will be the result of this NAND operator. So we have to remember it is a combination of NOT and AND. We have to perform the AND operation, and then based on the result we have to use the NOT operator against that AND operation. Okay, that's all about NAND operator. The next one is NOR gate. We can call it as bubbled OR gate too. So this is a logical symbol of NOR gate. So the NOR gate is basically the combination of NOT gate and OR gate. So the combination of NOT and NOR will produce the NOR gate. So here is the truth table for NOR gate. As we have seen before, here we have to perform OR operation first, and then based on the value we got, we have to perform a NOT operation. So as we all know that by adding two numbers we will get the OR operation. So here we got 0 1 1 1 as a result. So just opposite to the OR value, that is a NOR means NOT plus R. So we have to perform the OR operation and also NOT operation on R. So the opposite value of 0 is 1, the opposite value of 1 or 0. So here is the result, we got 1 0 0 as a result. So that's all about the NOR operations. So these are all the logic gates operation. Thank you.